Hello everyone, welcome to the next training session tutorial. This is the third session in the series of Java 8 in Selenium WebDriver, and I'm on a roll because this is the third session on third consecutive day. So let's see what we are going to have a look at in this session. We would see, well, to begin with, some more GAN on Lambda, then introduction to stream and map API, how Lambda returns a value, using predicate, static variable, and method references, and then we would see some of the WebDriver examples. So let's get started. Now to begin with, I want to show you some more example on Lambda because we would use it in this exercise. And I have a very small class here called testGround, which has a functional interface called myComparator, having one abstract method compare, which is to be implemented using Lambda. We learned before that functional interface is an interface which has only one abstract method. Now, if you see the next line, this looks a bit weird, but we have seen this in past. So what we have done here is we have instantiated our myComparator interface using the Lambda evaluation. Now, if you see here, what is happening is we have the implementation of comparator on the right hand side, and as we know from oops that we should deal with the assignment in terms of base classes and not the derived classes, so we have assigned it to a base class here. This whole syntax could also be replaced with anonymous inner class, which we had seen in the previous session. IDE might help me here in doing that. For example, replace lambda with anonymized inner class. So this is the same syntax here with the initializing my comparator interface using anonymous inner class. Now we don't want to use anonymous inner class anymore, so let's replace this with lambda. So what we see here is that lambda expression is assigned to my comparator object. Now what we do in the main method, we initialize testGround class. So we have an object of testGround class, and now we can call the my comparator object using testGround, and in turn we can call the compare method because my comparator is having compare method. So we have testGround dot my comparator dot compare, and then we are comparing with 10 and 11, and we know that 10 is not greater than 11, so this is going to print false. Let's run this. So we get false here. So what we see here is that we can assign a lambda expression also to an object. That's all, simple. So let's begin with the map examples and see what we are going to learn here. So I have another class here called map example. By the way, I'm going to post all of this code set on my GitHub account, and I will link it to the description of the ticket. And in case you are new to Java and new to Selenium, then please do not start here. I would also link my initial training sessions training session URL on the description of this video, so you can get it from there. All right, so let's start with learning what is a map in terms of lambda. But before that, let's see a small exercise without using the map. What we would do in this exercise is we have a list here of numbers from 1 2 3 to 11. We would find the first even number which is greater than 4, and then we will triple it. I repeat, we will find first even number greater than 4 and we will triple it. Let's do this without Java 8. So how do we do this without Java 8? We would iterate through the list using for each loop. So for each element in the list, we say get me something which is greater than 4 and get me something which is even, which means when we divide it by 2, we get a 0. Now, if these conditions are satisfied, then what we do, we store the result of the list element multiplied by 3 into an integer variable, and then we break the loop and we just print it. Simple. We find first element greater than 4, which is an even number, we triple it and we print it. As simple as that. Let's run it. So the first even number greater than 4 in our list is 6, not 5. 5 is not an even number, 6. And 6 is multiplied by 3, so we get 18. There is no Java 8 happening here. So let's see this example with Java 8 now. Let me comment this section and let me bring this section into the play. Now here we have list which is being exercised using, well, we have seen this in past as well, stream API, And now what we have to do is we have to filter it on number greater than 4 and then numbers which are even. If you remember, we did exactly same operation in the previous exercise with list. So we are calling something called method reference here. This we defined in the previous session. So I'm just calling the methods from previous session on the filter operation here, which is greater than 4 as well as is even. And then we are doing something miraculously different. So what we want to do here is we know that we have to multiply the result set to 3, and this is wherein map comes into the picture. So what does map do? This is another API which we have on the stream interface. Map takes a function argument which is itself a functional interface, and we know by the definition of functional interface that it would have one abstract method, only one abstract method, and this abstract method is apply here, which takes an argument which is t, and then what it does is it applies whatever function we declare on this argument, and then it returns the result set. So let's see what we have done. What we have done here is we have map, which is taking a functional interface, which in terms means, lambda implementation here of this functional interface. And we saw that this functional interface has one method, apply, which takes one abstract method apply, which takes an argument. So this argument we have seen before also should go on the left hand side. So if I come back here, not this one, sorry, map examples here, yeah. So one argument, this goes on the left hand side and the implementation goes on the right hand side, and I have mentioned this in parentheses. And what is the implementation here? Well, we have to multiply the number with 3. That's all. So this is a simple implementation. Now, if you notice this closely, I have specified the return statement here because we have to return this value. But idea is highlighting this and says that, okay, there are two things here. First thing is we do not need parentheses. Second, return is sort of hazy, which means that return is also not needed. So I can just do n multiplied by 3. So for example, I'll take the suggestion from IDE and I'll say replace with expression lambda. So we can just write n, which is an argument for functional interface called function here. Once again, yep, function. And the implementation is on the right hand side, and what map would do, map would apply this logic, this function on the argument here and then return it. Simple. Notice one thing, that this map, this word, this terminology is not same as what we had seen while learning collection API. Map is also not part of collection, but this map, what we are reading or learning here is completely different from the map we had seen before. So objective of this map in the stream API or stream interface is to apply a given function on the argument and then return the corresponding stream. So if you see here, the stream which is being returned here is a stream of integer. And then we had seen earlier that on stream we can call something called find first, which would give us an optional element, and then we can get one element out of this optional using get. So this optional may be empty, which is why compiler kinds of says that you should first check whether it is available or not, but we will see more of optional in details in future sessions. So let's focus on the map here, which I repeat again, what we did was we took the element from the previous stream here, which is coming from filter, and then the element which we receive, on this element we apply this function, which is n multiplied by 3, and then we return the resultant stream, which is a stream of integer. Very simple. Let's run it. So we get the same result set here, 18. We have a couple of print statements, and we have seen these before also in the previous session, that we are having lazy invocation here. So first filter is called until unless the filter on the condition of number being greater than 4 is not satisfied, next filter is not invoked, and this is the same thing happening here. So until unless we reach 5 is even is not called, and then after 5 we have again conditional check happening on this greater than 4 because 5 is not even. So we have 6 come in, and then 6 is even. So 6 is multiplied by 3, and then eventually 18 is printed. Simple. So let's see what we have next on this class. Let's comment this out, and let's comment the previous section and comment out the next one. Yeah. Now what we have is we are using predicate, and again method references here. Now in the previous set of statements, we had something called is greater than 4 as method reference which was being used, but instead of using method reference, what we are using here is we are using a reference to predicate here. So we saw this example before in something called test ground, that we can assign lambda expression to the type to which it implements, which was my comparator here. And in case of map example, we know that this implementation of this lambda is of type predicate, and this is of integer type of predicate, so this could be assigned to this predicate. And further down in our example, what filter does is filter takes a predicate, so we can replace the predicate with is greater than 4, because is greater than 4 is an instance variable for the predicate. Simple. So instead of using method reference, we can also directly assign the reference to it, which is a static member in this case. And then next of the code remains same. We have filter happening again using the method reference. Then we have changed something else also here. We have removed, the syntax or the expression from lambda to again method reference here. So we have a method called triple it. Let's see what this method does. Very simple. Method takes an argument and triples it, and this is what is invoked in the map statement here. Rest of the set remains same. We have find, first, and get. So if I execute this, we should get the same result. Yep, so we again get the 18 being printed here. So did we miss something? No, we saw how lambda returns a value. We also saw predicate. Now let's see how this works with the WebDriver. So I have an example of map with WebDriver, and let's see what's happening here. So this is our example using, well, we would first see how things happen without Java 8, and then we will see with Java 8 and Lambda. And our exercise here is what we want to do. We want to find out all of the links which contain word test on the registration page, and the length of the word should be greater than 4. So this is something which we had seen before also. But then what we want to do is we want to create a new collection out of this, and then we want to append a word called new data to each of the element of the previous collection, and then return a new collection. So let me repeat the problem statement once again. We want to find out all of the links which have the word test and the word length is more than 4. Once we get such links, then we collect all of the text from these links, and then we add word new data to the existing text, and then create a new collection and return this collection. So let's see how do we do this without Java 8. So if you want to do this without Java 8, first what we need, well, we need our link elements to collect all of the links from the registration page, and then we need a placeholder which is going to collect all of the elements which satisfy the first condition. So let's see how this happens. We have the link elements here. We iterate through link elements using for each loop. We are very well aware of for each loop. So we have web element here. Each element of the link element is collected into web element, and then what we do is we get the text of this element, then we store it in a string object, and then we compare, does this string object have test? If it has test, then we start filling our next list, which is list containing the word test, and we add the link text to our new list. Simple, isn't it? And now what we do here is I see that I have missed one condition here. I missed the condition about checking that word length is more than 4. This is not right, but let's see what outcome we get. Or we can modify this condition. Let me modify this. So we get the link text here, link text. We convert this into lowercase, and we specify whether it contains test or not, and let me modify this condition here. Not this, not this, yes, this. And so link text dot length is greater than 4. So we have both conditions now. So we have a text containing word test and the length greater than 4. In that case, we start filling in our new list. And now what we have to do, we have to satisfy the second statement now. So we have to create a new list out of this, and we have to fill this new list with the previous list, but we have to add a new data set or a new word which is called new data to each element of the previous list. So let's do that now. So this is a placeholder list called new test data list, and now what we do, we start iterating through all of the elements of this list containing word test, which we collected here. So we have for each loop a string, because this list contains string objects. We can specify any variable name here. I have used word, and then all of the elements one by one start getting collected into the word here. And then what we do, we have to fill in our new list, which is new test data list, and we start adding word to the new test data list. But what we do, we just concatenate new data to it, and in the end we are printing all of this. A bit fuzzy, but I hope it's easy to understand. So till here what we did was we found out all of the elements which contain word text and whose length is greater than 4. We created a list out of all of these elements. And on the next list, what we did was we iterated through the previously collected list, and then we created a new list out of the elements of the previous list by concatenating word or the string new data to it. So let's run it. I need to change the configuration here because we need test ng now. Yep, let's run it. So the application is launched and test run is over. Let's see the outcome. So our outcome is we have a list containing word test. So we have some elements in this list. First element, so you see the word test here. Second element, word test here. Third element, word test here. And this is the fourth element after the comma and word test here. And finally, we were appending new data to it. So our new list becomes no automated testing, and then new data is added to this. So this is converted from no automated testing to new automated testing new data. In the similar way, load testing tutorial is converted from load testing tutorial to new data. In the similar manner, new data is added to the third element in the list and also to the final element to the list. Now let's try to do the same exercise using Java 8. So what I would do is I would comment this section so that it does not print out when we are trying the next one, and I will comment out this one. So the objective remains same, but we would use Java 8 now. So let's start streams. So we have link elements already here, which we collected from the registration page, and then we get a stream over this, and then we start filtering. So what is our first filter condition? First filter condition is to get the elements whose text contain word test. So we know filter takes a predicate which has a method call. The method is called test, which takes one argument, and we have seen this before. Argument goes on the left hand side. What kind of stream we have? We have a stream of elements here, so it goes here. You can give it any name, whatever you want. So for example, I can rename it using Shift F6, so I can just name it E. It doesn't make any difference. And on the enter, yep, it doesn't make any difference. And on the right hand side, we have the implementation, which is the same implementation we have seen before. From the element, as in the web element, we get the text, we convert it into lowercase, and then we check whether it has test or not. you may have noticed that we never have to specify, that this is of some type, which is type web element. The stream is going to contain web elements here because compiler infers it. And then we have a second filter wherein we compare whether the text length is greater than 4 or not. So again, we have same syntax. Argument goes on the left hand side. We can give it whatever name we want. Let's name it web element. Web element dot get text dot length greater than 4. Now we had seen the map API previously on the previous class, which was the map example, and this is what is being called here also, but the transformation is quite different here. Earlier we were multiplying a number, but here what we want to do is we want to concatenate each of the element which we have a list with a text called new data. So what we do, we get the stream of list from here, a stream of uh, elements from here, web elements, and then we start mapping them. How we map them? We say, okay, again, get me the text of this element and then concatenate word new data into it. And eventually what is returned out of this map is, if you see here, it gives us another stream of a string. And we have seen before that we can collect this into a list using collect API, which takes collector, and collectors is a sort of util class we have seen before, and it has different ways to deal with the different collections. Here we are using collectors.toList. So we are collecting all of this to a list called test data. This is what is being collected here. So if I try to highlight the type here, is type is, or the return type is list of type string. That's all. The difference in this session in comparison to previous session is this map API. So let's see this once again. What we do in the map is whatever stream we get from the previous operation, which is filter here, which is a stream of web element, we map using the map statement here. So the map API would take an argument for function, and we saw before function is functional interface, which has one apply method. It takes one argument, it applies the function on this argument, and then returns it. And what we have here is we have our map, which takes element argument here. What we are doing in terms of transformation here, we capture the text from this element, then we concatenate new data word to it, and then we are returning a stream of string here, and finally we collect this into a list. Simple, isn't it? Now the point to note here is that this was such a big set of lines here, 2 for loops, and here we have pretty small setup to carry out the operation. And eventually what we can do is we have our this new test data. I am printing it here using using for each. And then what I'm doing on the next statement is on the registration page for each of the element in test data, I'm entering the first name. So let's assume that you had an exercise in Selenium while working with an application that you had to capture some text from some links, and then you have to add some test data or some sort of a string, and then you have to key in this into an input field. Then this is something which can be achieved using the for each statement here. And let's run it now and see what happens. It will be quite fast, so let's keep close eye on the first name element on the registration page, because we would have lots of data sets being input there one after another. So let's see here what's happening here. You see lots of test data were keyed in, and then control came to the last statement. Let us debug it and see how this happens on the debug mode. So we want to keep a debug point here. We just click here on the left hand side, and then compiler asks you where you want to keep the debug point. I'll say I want to have a debug point on data, and let's run it on a debug mode and see what happens. Well, not the compiler, the IDE asks for the debug point, sorry. And yes, control comes here, and you see first data set is no automated testing new data. So this should be keyed in here as soon as I continue. So first continue, you see the first data set is keyed in. And then if I continue again, we have next data set, which is load testing tutorial new data. So then this is keyed in load testing tutorial new data, and then other data sets are also keyed in. If we have a look at output of this method or the statement run, we have 4 data sets being printed here, just like before when we were not using Java 8, and they all have the word test, capital letters, small letters, small letters, small letters, and everything has new data appended to it. So this was about the debug point, and let's see what's happening in the next set of lines. Let me comment this, and let me comment this out. Yeah, so we have used something called method interface again here, because if you see the filter previously, you may end up making such comparison again and again. So we abstract it out in something called has word test method, and this takes an element and then does comparison for us using another method which we had created in the previous session, which takes an element and says, let me get the text, let me convert it to lowercase, and let me check whether it contains the word or not. Nothing new is happening here. We had seen method references many a time in past as well. Then filter is the same, map is the same, and then we collect. If I run this, outcome is not going to be any different. We are just printing the final outcome here, which we have for the test data list. So if I run this, we would get the same result set of 2 elements after elements are collected and operations are carried out. Let's come to the run. Yep, so we have all 4 elements here. So remember, if whenever you are iterating through a stream, you're applying some filters, and then you have a need to transform this to a different collection on the basis of some functionality, then this is something which is achieved using the map API, which takes argument of type function, which has an apply method, and we have to specify the logic or the function which has to be applied on the element. That's about it. What else? We have reached end of this session. I would, as usual, upload the code example on GitHub and link it on the description of this tutorial. And if you find this session educational, then please hit the like button, and I will talk to you on the next session. Stay safe. Bye bye.